You will want to use this video if you have been assigned 5.2 Reteach. So we're just going to be going over the difference between rates, unit rates, and equivalent ratios or rates today. So a rate is anything that compares two different quantities, like apples to oranges, miles to hours. So anything that is different. So let's say that our friend can walk or run 15 miles in 3 hours. So 15 miles to 3 hours, or 15 thirds. So she walks 15 miles every 3 hours. The unit rate is when we're comparing the second number to a 1. So I want to know how many miles she walks every hour or per hour. I need to take the first number and divide it by the second one. 15 divided by 3 is 5. She can walk 5 miles per hour. So if we made some equivalent ratios for those, if I say she walks 15 miles in 3 hours, I could say that she walks 5 miles in 1 hour. 15 divided by 5 was 3. Whatever I do to the top, I have to do to the bottom. 3 divided by 3 is 1. I could make these bigger, and let's say she doubles the amount of miles. So 15 times 2 is 30. So 3 times 2 is 6. It would take her 6 miles or 6 hours to walk 30 miles. So equivalent just means you're doing the same thing over and over again. Unit means you're making it into 5 miles every 1 hour. So we're taking that second quantity and turning it into a 1 with a division problem. And a rate or a ratio is just the basic facts that the problem gives you. So let's try another one here. So Mac's father drives tractor trailers for a local shipping company. His truck is traveling at a constant rate of 65 miles per hour. So we want to know how fast he goes every hour. So it just told us right there, he goes 65 miles in 1 hour. So if he continued that, if he went 2 hours, then I would take 65 and times it by 2 is 130. So he would drive 130 miles. So if he goes 3 hours, I'm going to take 65 and times that by 3. So 5 times 15, 18, 19. So then he would go 195 miles. If the problem was backwards and it told us that he went 195 miles in 3 hours and it asked how many miles he went per hour, then we would divide. But if he's going at this constant rate, then we're adding the groups on here. We can also put that on a graph here. So he went 1 hour. So here's our time. 1 hour, he went 65 miles. In 2 hours, he went 130. In 3 hours, he went 195. It was just repeating that same constant over and over again. Hey, let's try one more here. So Victoria's family is driving on vacation. Their car is traveling at a constant rate of 60 miles every hour. So after the first hour, they've gone 60 miles. After the second hour, they've gone 120. After the third hour, they've gone 180. After the fourth hour, they have gone 240. I had to think there. 6 times 4 is 24 with the 0. So now let's take a look at under here. And it wants to know, what are some equivalent ratios for this? So every hour, she goes 60 miles. 60 hours per mile. That means it would take her 60 hours, so more than 2 days to go a mile. That doesn't sound reasonable in a car. 60 miles per hour, so that one sounds good. 120 miles in 2 hours. That looks good. Takes so if I do 120 divided by 2, that's 60, which is 60 miles every hour. This one says it takes 3 hours to go 180 miles. That's correct, but we've got to put the hours on the bottom because that's what we're dividing by, is the hours. Up here, it told us per hour, so hours should be on the bottom. So that one is backwards. So our two equivalent statements are 60 miles per hour or 120 miles in 2 hours, which simplifies if I divide them both by 2. 120 divided by 2 is 60. 2 divided by 2 is 1. 60 miles per hour. Hey, go ahead and try your reteach and let me know if there's anything I can do to help you.